students, it's Mathline time. You've turned in the right question. Hey folks, welcome on this first Monday of November. I'm Ernie Roberts. You're watching Mathline. You're with us. Stay with us. We are glad you're with us today. All that good stuff. Just stay with us. It'd be great. I'm Ernie Roberts once again, and we host a little show called Mathline here. It's where you can call in your math problems, and we have a phone operator today from the Bearden High School Key Club. Harshi's come back to help us there. Good to have her with us today. Thank you for coming out. Last week we had Autumn and Tarek from Fulton High School, and we appreciated their work too. So these Key Clubs are working for us. If you and your students would like to help us out and answer phones someday for us here in the studio, we'd love to have them. All we need is a couple, and we'll keep you social distance with that many, and we take care of business there. That number, by the way, so Harshi can get to work, 844-686-2378. Again, 844-686-2378. Give us a call in here. You know, it's before Election Day. Tomorrow we're not going to be around because PBS nationally is going to start their coverage early. So just be aware of that. If you don't see us here, we're going to be back Wednesday, all right? But today's your day to call. Again, that number, 844-686-2378. Now, you've been waiting for it. Let's get to the problem of the day. Problem of the day, Eli. I want to think that Three Dog Night song, Eli's Coming. But anyway, Eli has 100 books to place on 6 shelves. Let's give him 2 more shelves than he has. He wants to place 18 books on each of 2 shelves. So he's going to start with 2. And then he's going to come up with the same number of books on the remaining shelves. How can he do it? Wow, how can he do it? And Facebook's already been asking us, and they've been sending some good answers and some good strategies. And I'm going to, you know, Ernie Roberts is going to probably use algebra in this, but this is one of the processes you don't have to really use algebra. You can use what we call algebraic thinking and work this thing out in your head. So let's see what we're going to do, all right? And we're going to look at both ways. I'm going to do some algebra with it. So let's take a look at it and see what we've got going here. First of all, we have 100 books total. We know that. We have 6 shelves to put them on. He wants to place 18 books on each of 2 shelves. So we're going to start with 2 of them with an 18 and an 18. And then we're going to have the remaining shelves, well, there's 6 total, right? So that tells me we have 4 more to fill in. Now, since I don't know what they are, you know what I want to do? I want to put an N standing for the number of books, all right? I could do that. You put a question mark, you put X, whatever you want. But the idea is all of these give me a total of 100. That's the storyline, basically. So ways that you can figure this out without doing, quote, any algebra, but like I said, algebraic thinking, because what we actually write here eventually is going to look like algebra, okay? And what we do in our head is like algebra. We're solving a problem. So let's see what we've got. First of all, we've got 18 plus 18, which is going to give me 36. That means I've taken care of 36 of my books so far. So how many have I got left over? That would be the idea. And I'm going to try to spread them evenly. Eli is going to spread them evenly for us, okay? And how can he do it? We got to know how many we can put in each shelf, on each shelf. And will we come back with 100 in the end? That's the big question also. So let's see what happens. If we have 36 books already claiming their spot on the shelves, we have how many left? We've got 100 minus 36. You can hit a calculator. You can do that in your head. Some of you are going like, ooh, I don't have that much money. I can't think of what to do with money. So let's do a quick look on the calculator, and let's see. I'm aiming for 64. And let's see if that doesn't work out correctly. We'll subtract that 36 if my mouse will let me. And there we go. We got 64. So what we're going to do, we're going to split that 64 up evenly 4 ways. That's the hope. Can we do it? Let's find out. Let's go ahead and take that and divide it by 4 and see how many books we're going to put on each. We're going to have 16 on each shelf. Well, that makes pretty good sense. It's a little story. It really is. So again, that's the process. And notice what I did. I subtracted 36 from 100. And then I took what I had left and divided by 4. Now, let's see what that looks like in the land of algebra, okay? It's an easy transition, my friends. Let's put an N here, an N here, an N here, and an N here. So you get all excited when you see letters, and not in a good way. And others you get, yes, 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 we love algebra. And that's kind of me. I'm one of those N for nerd types, or N for number here. So let's put down over here somewhere then, before we get rolling into this thing, we're going to piece these things together also, because they look a lot alike to me also. So this is all about the books. And N equals the number of books, not total number of books. We've got that as 100. We got 38 here, and 64 is not what N equals. It's the what? Let's define our variable and be very good about it. The number of books on the final 4 shelves. On each of the final. We just work that a little bit. Well, we're going to be specific, aren't we? The final 4 shelves. So in other words, that's what it is. Each shelf is N books, N books, N books, N books. Now, piece this together. Notice I put these already together. We know it's 36. And we got an N, an N, an N. How many are there? 1, 2, 3, 4. And that's where we're going to go. 4N equals to 100. Now, what did we do on the calculator? Don't go back to it, guys. I'm just wanting to ask our audience here and our folks who are tuning in. What did we do? We subtracted this 36 from 100 on the calculator, did we not? That's exactly what we're going to do first here. We're going to work this thing just like our thought process was. And that's what we're doing with our algebra. We take our thoughts and put it on paper. That's the idea. So let's take those out, and we're going to have a 4N left over, and over here we have 64. Now, what does this say? 4 times something gives us 64. Do you see how this connects? I know a lot of our younger folks, and a lot of our older viewers too, go like, I can do all the arithmetic. And that's precisely what you're doing. But you're just putting it into a language form here when we do the algebra. And by the way, that means we're going to divide both sides by 4. Or we could just go ahead and divide 4 into 64. And guess what? We do have N equals 16. That is 16 books, per shelf, right? 16 times 4, of course. It has to be 64, right? And we have the 64 and the 36. We are back to 100. So our whole story takes good help there. Eli, you now know how many books you need to put on each shelf. He's probably already taken care of that. And again, that's the kind of concept. I want you to realize that a lot of the math we do in our head, yes, we can. We think algebraically. You just may not have realized you did some algebra there. But you do when you add those together, subtract it from 100, and then you have 4 remaining pieces to divide evenly. How about that? A little bit of a connection for you. And I understand I have a caller waiting for me. So speaking of connection, that's great to have someone calling in this afternoon already. And welcome to Mathline. Who am I talking with this afternoon?
Hi, Ernie. This is Joe again.
Hey, Joe. How are you doing?
Oh, pretty good. How are you doing?
I'm doing all right, doing all right. It's a little crispy out there today. I feel a little hint of fall finally around here. A big hint of fall, I should say. So, what you got for me today? I have one problem I was going to refer to that you'd sent me on email, but if you've got another one, feel free to throw something at me here.
Well, it might be the same one. I want to divide the algebraic. It's going to be finding the difference of 2 cubes. So we're going to divide, open parentheses, 125u to the 3rd power.
Okay, hold on just a second. Minus, was it, because I saw earlier 64 something, isn't it?
Right, 64v to the 3rd power.
Okay, so we have perfect cubes there, folks, and some of you are like, what? It was a perfect cube. We'll find out. We'll talk about that here in just a minute. And we're going to actually divide it by something else, too, if I recall.
Divided by, open parentheses, 5u minus 4v as in Victor, close parentheses.
Okay. And others are already, their little eyes are glassing over out there, and others are just chomping at the bit to see what's going to happen here. I can feel all this different kind of intensities going on out there in the world of watching PBS Mathline this afternoon. So let's talk about these. First of all, it is the difference of cubes here. We've got two perfect cubes. And folks, if you're not quite sure what I mean by a perfect cube, if I said a perfect square, it's sort of like 25. 5 times 5 is 25. But if I want to bump another 5 in there, 5 times 5 times 5 gives us 125, and that's what makes this a perfect cube. Now, anything with an exponent that is divisible evenly, completely divisible by 3, is a perfect cube also. So, in other words, the cube root, we'll say, of u to the third is u. Not u, but u, the letter u. And the cube root of 125 is going to be 5, because 5 times 5 times 5 gives us 125. So it's just taking those squares and going one more power up the ladder, so to speak. We go from squares to cubes, and we also deal in square roots versus cube roots. This one is about the cube. So I'm going to do something here, Joe. I'm going to put a 5u, and I'm going to rewrite this thing as 5u parenthesis with a cubed on it, okay? And I'm going to rewrite this one as a parenthesis, because what I'm seeing here is this little guy here, right here, says, we'll say 5u is our value that we're going to be worried about, as is the 4v. U's and v's look a lot alike, too. I always wish they'd put, like, X's and Y's, or, you know, something. P's and Q's always wear me out too when they put those variables in there together. But anyway, what we got a little formula, all right? We got a little formula. I'm going to write it down over here to the edge. And it says, if we were to take, and I'm using U, it can use X, whatever. But if I didn't have a 5 and a 4 there, what I would be saying is that this is equal to the cube root of U cubed minus the cube root of v cubed, which is just u minus v. Okay, so basically you take these things, take their cube roots, and write as a subtract symbol. Now, the way I would teach my Algebra 2 students when I used to teach some of that was I would say, okay, we're going to square this term, and then we're going to multiply these two guys together, and we're going to change the sign. Now, this would have been negative if I'd multiplied. We're going to make it go positive. And then we're going to square the last, which is a negative v times a negative v, or opposite of v, opposite v. Anyway, we come up with v squared. And I ran out of parentheses. Sorry about that. All right, so in looking at what we've got there, I'm going to take the u and replace each of those with a 5u and a 4v. All right, because that's what we're talking about. You see what I'm doing?
I'm trying.
Okay, so what I'm going to do, this is the general formula, okay, general formula. You might have had A's and B's. It may, with my putting U's and V's in there, might not have been the best choice there to do, probably. But what I want to do is I want to come back and say, okay, instead of U, what if I put a 5U and I'm going to put, everywhere I see a U here, I'm going to put 5U, is the idea. Put, first of all, this parenthesis says that I should be able to get 5U minus 4v. I've already broken this part down. Now, you saw where I got 5u and raised to the third, right? You follow what I did there?
Yeah.
Okay. So I'm going to put that in for my first parenthesis, which I think, from what I remember seeing of the problem you sent me, that's where you started, right? You had a parenthesis. And then the question is, what's going to happen there? Now, folks, we haven't gotten here yet, okay? That's later, okay? We're just going to worry about breaking down this craziness right here. So that's the first thing. So right now we are trying to work this part out. And hopefully in the next 5 minutes we'll have it worked, okay? Let's see. Now, what I said, we're going to take the 5u and we're going to square 5u. We're going to take 5u times 5u, which is going to give me 25u squared. Now, Joe, I want to tell you something. If we take 5u times the 25u squared, we are back to 125u to the third. So in other words, we're taking a binomial. We're going to create a trinomial, and here's what's going to go on. Because this was basically what we're looking at. It's a binomial times a little trinomial here. So I know I have to multiply those two eventually, and that's how I get my 125u cubed back. Okay? So that's my starting field right there. Now, remember, let's go back to what I said here. Once we square the first, which we've done, u squared, we're going to multiply these two terms. This happened to be u and v here. I'm going to multiply 5u times the negative 4v. But I'm going to do one other thing. I'm going to change signs. I'm going to change the signs on because I have to get some sort of cancellation going on in the middle. And I have to have it in order to get something to cancel. Otherwise, I've just got a bunch of murky, muddy-looking terms. Okay, and I don't want that here. So I want it to come back to something very straightforward and simple there, as simple as we can get with with 125u to the third minus 64v to the third. So again, we're going to multiply this 5 times 4, which gives us 20. And changing the sign, and we're bringing along a u and a v for the ride. And on the end, we're going to square the last, as I like to say. We're going to get negative 4v times negative 4v, which is going to give us 16v squared. Now, Joe, I'm going to tell you something, and that's another reason it's very important here, because we're going to have this minus 4v and the 16v squared, and that's going to give us minus 64v to the third. So these are how these pieces right here fit. Now, why do I have to have a 20uv here in the middle with a plus? Because I want to make sure I can mix it in with the 5u and the 4v and all the other good things. I've got to come up with basically 6 terms if I multiply them all out. I don't want to go through that right now, but I've got to have something to cancel out. So that's why I put the plus in there, and that's where we are. That's factoring this first thing. So what I want to do is I'm going to take this expression, and you said we're going to divide it by this, right?
Right.
5u minus 4v. And what just happened here is these two cancel out because they're identical terms here. Whatever you put in for u and v, you're going to get in both places here. As long as they don't make a 0 happen, we have those to cancel out, like 7 over 7, 8 over 8. 5u minus 4v over 5u minus 4v. It's basically the same thing. They're identical. So they go away. And this is what you're left with. And I think that was one of your choices. I think it was the correct choice, hopefully, on your key. And I'll tell you something, what would have happened, and that is plus 16v squared. There's a little square there, folks. Now, what that would have done, the only difference would have been if we'd had a plus here, we would need to have a plus there. Because what would happen is you would end up having 5u plus 4v times 25u squared minus, there would be a minus there. So whatever the sign is here, that sign has to take the opposite in order to get the cancellations from some positives and negatives working together. And then you would end up with whatever sign you wanted on the end. In this case, it would still be 16v squared because when you square something, it goes positive. So this is the sign that makes things happen. If this is minus here, we put a plus there. If it's plus here, we put a minus there. Everything else works the same way. Hope that helps a little bit. It's a process. We actually, I think my second year on Mathline, we did a show on the difference of cubes, factoring them, and also the sum of cubes. We did one day on each. And they're way back on the files. I don't know if they got on YouTube back in those days or not, but I think it was my first season maybe that we did Mathline. We did some factoring of some intense factoring on here, and that was one of the examples that we went to one day, 2 days actually. So we've attacked them, we've done them, but no, you mentioned and again, let me, while I'm talking with you folks, also remind you that there are others of you out there who have questions. Give us a call. It's all right, 844-686-2378. They don't have to be that extreme as Algebra 2 and some of these longer type problems, but feel free to give us calls, and we'll see what we can do and tackle them together live on the air. Now, Joe, you did send me one that I did print out. I was going to actually pull to us today, so can we take a look at this one, guys, down there? Yeah, there we are. And that's okay. It's everything's in there that we need. I realized it was running into wasn't thinking about that when I put this together. But Joe sent me this expression, says x to the fifth minus 81x. And it says factor completely. And I'm going to tell you, because you were questioning me about, it seemed like all of them would work. Well, most of these are a factorization of x to the fifth minus 81x. The only catch is that word completely. And that's what is factor completely. So you've got to take it all the way down. And that's why only one of these is the best and the correct final answer, actually. So let's see how we would do it. Joe, first of all, I see a GCF. Do you see a GCF, greatest common factor, in this problem? We can slide out x there. This is the x fifth minus 81x that you sent me. And we have left over.
The reason I'm asking you is because factoring is something I just don't get.
Okay. All right. Well, first of all, now, I pull out the x for a simple reason. I see perfect squares now. I see a 4, which x to the fourth is x squared times x squared. And I see 81, which is 9 times 9. So that's what I have to first look at and see, is there anything unique about my terms? And in this case, I've got what we call the difference of two squares. So I have divided the x out in order to lose these odd exponents, because I really don't know anything about how to factor x to the fifth, nor do I really care. And with the x there on the end, that took away the possibility of having a perfect square with 81. So that's why we did that first. And I noticed that is your A suggestion, okay? You see where that came from. That's just from looking at the GCF. The idea is we try to get this thing down as simplified as possible. We've got big exponents. We'd like to get it down to small things, the smallest pieces we can go. So with the x, it's done. It's just going to go along for the ride. But inside here, I have perfect squares. And when we have the difference of those perfect squares, we can break them open into what we call a sum times the difference. And when I say sum, I mean we're going to say x squared plus something, and x squared minus, I've already put it in there, 9. We're going to put a 9 in there also. Now, Joe, it just is impossible to break open x squared plus 9. Because if I tried to make it like an x plus 3 times x plus 3, I'd get a pesky 6x in the middle when I try to multiply those back out. Just like on the problem we just did with that difference of cubes, I had to find something that made everything disappear in the middle, so I could just have 125 and the 64 attached with its u cubed and v cubed. So here I'm finished again right there with that part. All I've got left to do is another difference of squares. And that breaks open into plus minus combination. And let's see, we're going to have x minus something, x plus something, and since I've got a perfect square in 9, I can do that. If I didn't have a perfect square there, I'd be done. Problem be over. But I can mix the 3 there and the 3 here. Now, why is that different than this one? Because if I look outer, I get x squared, which is lovely. But I go inner, I've got a negative 3x. I go outer, I've got a positive 3x, and they cancel in the middle when I'm doing my FOIL routine. So basically, factoring is a reversal of FOIL. And when these cancel out, that's where we are. Over here, once again, these can't go any further. So what we had, part B right there, that was what we had in basically the third step here. After we wrote the problem down, we took out the greatest common factor, we got one step further, and then we got one more place to go. And this one is your best, because you've gotten all the way to the very end. Now, over here, this one looked tempting. That's for the students, or that's for the person who's taking the test, to think, oh, I get x plus 3 there, and that would make that become the factor completely moment. But that's not what we want. That one is really the one that's really totally bogus. The others are just steps along the way. So does that help a little bit?
A little bit, but it's pretty difficult. I mean, you got to like reverse engineer. I mean, I don't see the method of figuring it out. I mean, I see how you do it.
I'll do one real quick now. I've got about a minute here left, I think I can do. Going back to where thank you, a minute and a half, they tell me. We've got x squared plus 9 and x squared minus 9 there. And again, the whole process when we do a binomial is we FOIL. So we take first, and we'll get x to the fourth. We get outer, we get plus 9x squared. Go inner, I get minus 9x squared. And to my last, I've got minus 81. So that gives me x to the fourth. These cancel, minus 81. So what I'm doing is I'm just breaking these down into smaller pieces, into binomials. And in this case, I can do it one more time because it also has this difference of squares approach. So that's what that's about, okay? And factoring is just basically taking this FOIL and reversing it. It's taking it and reversing it. What your final answer here was, let's go back. Just so much of math is like, let's go backwards and forward, okay? Hey, Joe, I'm going to have to shut us off here for today, but thank you for submitting those, and thank you for calling in today, all right? Good math. Harshi, thank you for helping us out on phones today. We appreciate it. Bearden High Kitty Club, there she is. She took care of us today. Thank you. And again, folks, we're going to be gone for Election Day tomorrow, but we will be back on Wednesday. We'll be live and live on Thursday this week. So think of some problems, get ready to call us, and we'll see you again next time.